Hello everyone, this is Vasant, a ninepointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a couple of problems on Poisson's ratio. We already know that Poisson's ratio is important in understanding actual deformations of the member under axial loading, right? So to understand Poisson's ratio in a better way, we need to solve some problems. So this is our first problem. You can see over here. The question is, there is a high strength steel bar which is used in large cranes. The diameter of the steel bar is given and its E value is also given. The Poisson's ratio is 0.3. Because of some requirements, the diameter of the bar is limited to 50.025 mm when it is compressed by axial forces. Okay. Then what is the largest compressive load Pmax that is permitted? Okay, let us do the question. Let us directly take max load. So this is the rod. Suppose it is under Pmax. See, as you increase the compressive load, the diameter, the expansion in the diameter will increase, right? So in what is maximum load here? The maximum load is that load at which the change in diameter is delimited. Okay. So now the D max will be 50.0.25 mm, right? This is maximum diameter that a bar can have. So this is D initial is 50 mm, right? So we already know that Poisson's ratio nu is equals to minus epsilon dash divided by epsilon. What is epsilon dash? Epsilon dash is lateral strain, right? This epsilon is axial strain or longitudinal strain. So epsilon dash will be change in diameter del D divided by D. Change in diameter will be 50.025 minus 50 divided by 50, right? That is equals to 0.025 divided by 50. Okay. And epsilon, we already know that sigma is equals to E into epsilon. So that will give us epsilon is equals to sigma by E. What is sigma? Sigma will be P max divided by AE. Okay. So now let us put over here epsilon is equals to minus by nu. So that is, sorry, this is epsilon. So that will be is equals to P max divided by AE equals to minus 0.025 divided by 50 into nu. What is the value of nu? It is 0.3. So P max will be is equals to minus 0.025 divided by 50 into 0.3 into A into E. What is the value of area? Area will be 5 by 4 D square. What is the value of D? That is 50. We put it in mm and we put E value in megapascals. Gigapascals is given, so that will be 1000, right? So now we will get P max in newtons, right? So let us put it over in calculator. 0.025 into 3.14 into 50 into 50 into 200 into 1000, right? That will be this value divided by 4 divided by 50 divided by 0.3. So we will get P max will be equals to 654 minus 166 newtons. So that will be is equals to minus 654.166 kilo newtons. Okay, this is the answer for first question. So let us move ahead. So this is the second question over here. You see the question, a tensile test is performed on a bar cross specimen. The gauge length is 50 mm. So when the tensile load P reaches a value of 20 kilonewtons, first what is gauge length? See, we already know that when we apply a concentrated load, the stress distribution near the concentrated load will be non-uniform. So we neglect some area from here, from this end, such that whatever length we considered, that will have uniform stress distribution. So that part will is called as gauge length. Okay. So when the tensile load P reaches a value of 20 kilonewton, the distance between the gauge marks has increased by 0.122 mm. First, let us solve first question. What is the modulus of elasticity E of the brass? So we already know that sigma is equals to E into epsilon. Sigma will be P by A, that will be equals to E into epsilon. So E will be P divided by AE, right? So what is the value of P? 20 kilonewton. We need to put it in newtons. Divided by what is the value of A? Pi by 4 into D square. D is 10. So what is the value of epsilon? The epsilon value will be change in length divided by original length. Change in length divided by change in length is 0.122 divided by original length is 50. Okay. So E will be 20 into 1000 to 50 to 4 divided by pi into 10 square into 0.12. So let us calculate 20 into 1000 to 50 into 4 divided by 3.14 divided by 1, 2.2. So this is, we got E is equals to 104,416. This is in megapascals, right? Because we put P in newtons and D in mm. So the value of E which we get will be in megapascals. So E will be is equals to 104.416 gigapascals, right? So this is the answer for the first question. Now let us move to second question. If the diameter increases by 0.0080 m, what is the Poisson's ratio mu? We already know if we apply a tensile force, then in lateral direction there will be compression. So Poisson's ratio mu for B will be is equals to minus epsilon dash divided by epsilon. So what is epsilon? It is axial strain. Axial strain is 0.122 mm divided by 50. And what is epsilon dash? That is, see, it is decreased, right? So minus 0.00830 divided by 10 initial diameter. So mu will be minus 0.00830 divided by 10 divided by 0.122 divided by 50. Okay. So mu will be plus 0.00830 divided by 0.122 into 5. So let us put it in calculator. So 0.00830 divided by 0.122. So we get 0.34. Okay. So Poisson's ratio mu for this material is 0.34. So with this we end today's lecture. Thank you from my part.